Hello. In this video, we are going to be solving logarithms. It will be covered in two different sections, each of them being a little bit different and with different methods to obtain answers. In the first section, we'll be talking about solving logarithms where there is either only one single logarithm or there is a one logarithm on both sides of the equal sign, and they will be of the same base. And we'll work on solving some logarithms later where they are using logarithm properties to get to the same point. So let's get started. What you see in front of you is some review notes as well as some steps in order to solve these first kinds of logarithm equations. Remember that when you have a logarithm, the base is always the bottom number. The power or exponent is usually what it's equal to. Logarithms are equal to exponents. And then the input or answer from that exponential form ends up in the answer part, in which is usually in parentheses. So in these first examples, we're going to go to step one first, convert it right to exponential form, which we've practiced before. And then we are going to solve if there's like bases for x and get that exponent. In front of us, we see 5 different examples of this first type, all kind of similar sort of setup. So if we can start comparing these to each other and talking about these problems, we can look at number 1 first. Log base 2 of 32 equals 3x. So all you have to do first is convert it to exponential form. 2 to the 3x equals 32. And then use what we already know about solving exponential equations. If we know 2 to the 3x equals 32, well, that means that we just need to get 2 as a common base. So now we have 2's in the bottom of both. 2 to the 5th is the same thing as 32. And then since the bases are the same, that means 3x and 5 are the same. And we have our answer, which is right here. The other problems in this section are very similar. Ones like 2 and 3, 2 through 5 actually are all kind of similar in that in all of them, they are basically doing the base raised to the power equal to the input. So 3 to the negative 2. You can just put that right in your calculator and it'll tell you the answer is 1/9. So 1/9 is equal to 2x. And we would just divide both sides by 2 to get x equal to 1 over 18. Number 3, same process really, where we are doing 4 to the power of 2. And just that makes it 16 equal to the input of 5x plus 1. Solve that for x equals 3. And then 4 and 5, similar to number 3, where you're doing 8 to the power of 2/3 equals x minus 5. Put 8 to the power of 2/3 into your calculator, you get 4. And it's equal to x minus 5, giving you an answer of 9. And then 5, as you can see, is very similar as well. The next method of solving these same sorts of log equations are examples where you're going to have a logarithm on each side, but they already are equal to each other and they have the same base. So if you were taking log base 10 of something is equal to log base 10 of something different, well, that means whatever the inputs are also going to be equal. And remember to make use of your calculators whenever possible in this method. Let's walk through a few of these examples now too. So in these, we see in this first example, log base 2 of x is equal to log base 2 of 12. And you can see that they both have 2's on them as bases. So if we remember that they have those 2's in the bottom, we can just get rid of those logarithms. We can just cross them right out and get rid of them. So we know that x is equal to 12. 7 works the same way since they're both log base 3 and there's nothing else going on outside of these logarithms. That means we can just say that x minus 5 equals 13 and get that 18 is the answer. 8 and 7, basically the same idea, just a little bit extra algebra steps down here. And then finally, 9 is a little bit harder because now we have log base 2 on both sides. You can see that. So once you've gotten rid of the log base 2 parts, we have the x squared is going to be minus 6 is going to be equal to 2x plus 2. Just solve that quadratic, and you could do quadratic formula or factor as you see it in front of you. The answers you would get would be 4 and negative 2. And it's important that we'll talk later on. Some of these answers might end up being extraneous. For instance, if you put negative 2 into x, you would have 4 minus 6 equals a negative logarithm. And you can't really do log base 2 of a negative number, given that 2 raised to any power would not get you to a negative number. So we technically would have to cross out negative 2 as a possible answer, and it is extraneous. Next, we will work through these 6 examples as classwork problems for you to try, and it would be beneficial to pause here, copy them down in your notes, leaving room to solve them for when we do it together in just a moment. And while we're going through each one, it's also a good idea to pause it and see if you can complete these problems on your own before seeing me walk through them. We are now looking at the 6 problems that we were working on in our notes for classwork. Hopefully you have written down all 6 from earlier in the video, and we're going to go through each of them. So as we go through these, I'll pause for a second so you can try to work out 1 or 2 or up to 6 on your own. And then as you see me working on it, you'll know, are you doing it correctly? And this would be a great strategy for any student. So let's start by looking at x number 1. So I can see that it's log base 4 of 256 is equal to x plus 5. So now if I am going to try to solve this, I got to figure out, well, I'm going to do a 4 raised to the x plus 5 power equal to 256. So then I'll write that right underneath. 4 to the x plus 5 equals 256. And I just need to solve that exponential equation just like I have solved before. So I would write 256 as 4 to the 4th power equals to what I had already on the left side, 4 to the x plus 5. And then the 2 4s would be able to get kind of crossed out. And that would leave me with x plus 5 equaling 4, which means the answer here is x equals negative 1. Now I'm going to move on to number 2. So try to work out number 2, get an answer for x, see if it compares to what I'm about to go over. So first step is the same, 2 to the power of 3x minus 5 equals 1024. Let's write that right underneath. 2 to the power of 3x minus 5 equals 1024. You might need to use a calculator, but it turns out that if you do 2 to the 10th power, that is equal to 1024. And that would then be equal to 2 to the 3x minus 5. So now if you are trying to solve it from here, we know now that 2 and 2 can get crossed out, and we know that 3x minus 5 is going to be equal to 10. And if you use some solving equations, you would find that x would have to be equal to 5 once you've added 5 and divided by 3. So those are both pretty similar to each other, and number 3 and 4 are a little different because we're going to have exponential parts that don't have x's in them, so they'll be a little easier than the first 2. So let's look at 3 and 4 now. So we have number 3. So now pause the video, take a second to think about number 3, try to solve it for x. Now, if you did, you would have done 3 to the 5th power equals 4x minus 17. Let's write that first. 3 to the 5th power equals 4x minus 17. Now 3 to the 5th power, if you put that in your calculator, equals 243. The right side didn't change at all. And then you can just solve equations there, and you would get 260 equals to 4x. And that turns out that 65 is going to be equal to x. For number 4, similar to number 3, take a second, try number 4. So the first step would be the same, 5 to the 5th power equals 3 minus x. So let's write that, 5 to the 5th power equals 3 minus x. 5 to the 5th power equals 3,125, and that equals 3 minus x. Be careful with the minus x, don't lose that along the way. So if you subtract 3 first, you would have 3122 equals negative x. So negative 3122 would have to equal x. Very important step there. You can't have 3 minus 3122 in that logarithm. So we want to make sure that we did remember that last step. And finally, we have our number 5 and 6, and this is where we're going to be utilizing our next step of this process. So we want to think about how we get rid of these two logarithms. And if we know on the left side here that both of these are base 13, well, that means we can just kind of cross out the two log base 13s and know that x squared, this part in here, is going to be equal to the 3x. So we have x squared minus 4 equals 3x. Well, we got a quadratic equation to solve. First step of solving any quadratic equation, no matter what the problem is, we'll be setting it equal to 0 first. And so we would just be subtracting that 3x from both sides. And we would get x squared minus 3x minus 4 equal to 0. And then I factored it to x minus 4, x plus 1 equals 0, and got my two answers of 4 and negative 1. And that brings us to our last problem, just like number 5. Try it out, see if you can figure out how to get the answer for x. So let's start with first step, get rid of the logarithms. They're both log base 3. And so we don't need them anymore. We just will know that x minus 5 is equal to 3x minus 25. And we can set them equal to each other. And once we got in there, we just got our x's on one side, we got to put our numbers on the other side. And usually there's an easiest way to do that. So if I would try to keep the x's positive if possible. So I would subtract x from both sides, getting me a 2x over here. And I would add 25 to both sides. So that would give me a 20 on the left side. So if 20 equals 2x, that means that 10 is going to be equal to x. And that finishes these classwork examples of solving logarithm equations when there's either the same logarithm on both sides or only one single logarithm that we can convert to exponential form.